A warm welcome to all our TVET lecturers. I'm Amanda Skinner from Macmillan, and today I will tell you about NQF Level 4 of the exciting new NCV course called IT and Computer Science with specialization in programming and robotics. The course was launched at Level 2 in January 2023. In January 2025, the Level 4 subjects for this NCV course begin. The three subjects at this level are technical programming, electronics and digital concepts for robotics, and robotics and industrial automation, which is the subject I'm presenting in this video. Colleges will need the new textbooks to teach the correct content and prepare students for exams. The logo, New Curriculum for 2025, tells you that this is the correct book. Later, I will show you why our DHET-approved TVET FIRST Students Book, Lecturer's Guide, and Workbook are your best choice for successfully teaching this brand new curriculum. Right now, let's focus on knowing the curriculum.
What is robotics and why is it important?
Robotics is a multidisciplinary subject which involves all components of STEAM education. STEAM is an acronym which stands for Science, Technology, Engineering, Arts, and Mathematics. As different kinds of robots become more common in our everyday lives, it is important to integrate robotic concepts into educational curricula. Robotics can be a great preparation for students who are preparing for future careers.
How is this knowledge structured in the syllabus?
The curriculum is structured into 6 topics. Students will learn about robots and our lives, 3D printing, electronics and networks for robotics, components of a robot, programming, and practical robots.
What will students learn in each topic of the curriculum?
Topic 1 focuses on robots in industry. Students will learn about robot classification and the role of ISO in the robotics field. They will learn about the power sources of robots as well as their geometric reach and impact. They will study the importance of robots in industrial settings and the application of industrial robotics. Students will also learn about the different types of robotic automation and how to differentiate between the different kinds of control systems. They will also study further about the Internet of Things and the smart concept. Topic 2 covers the terminology and applications of 3D printing. Students will learn about the design, development, and practical aspects of producing and printing objects. Topic 3 is networks for robotics. This topic explores robot integration as well as networking and electronic communication principles as they relate to robotics and industrial automation. The topic includes protocols, configurations, and standard hardware used to facilitate data transfer and to link various robots. Students learn about how devices in an industrial network use a protocol or a shared language to exchange information effectively. They are also introduced to the concept of integration as the process of trying to achieve seamless data flow, greater flexibility, and optimized production processes. Topic 4, Components of a Robot, unpacks how robots are increasingly used in today's manufacturing and industrial environments. In this topic, students explore the main parts of industrial robots, including their different setups, how they move, their specialized end-of-arm tooling, grippers, and how wireless technology helps them function as smart devices. Students must revise Unit 4.5 of Level 3 and revisit Unit 1.3 of their Level 4 textbook to consolidate their working knowledge of the Internet of Things and smart devices and connectivity, as well as basic network concepts. Topic 5, which is called Programming, explores the essential role of programming in industrial automation. The topic highlights the importance of effective software to get the full benefit out of hardware investments. The section focuses on articulated robots and explains fundamental programming concepts such as frames and coordinate systems. Students also learn about microcontroller programming and programming language interface instructions. There are 3 practical projects in this module. By the end of Topic 5, students must be able to select the most suitable microcontroller and programming language for a project. Topic 6, which is called Practical Robotics, is about applying the learnings from other topics to develop robotic artifacts for real-work applications. Students create projects in which they construct and program robots to perform different tasks. There are 9 practical projects in this module for students to apply the extensive theoretical knowledge taught in this course. These projects present real challenges and problems commonly faced by roboticists.
What are the guidelines for teaching time?
This subject is offered full-time over 2 semesters, spanning 24 weeks, excluding assessment. This is equivalent to 2 double periods of about 1 hour 50 minutes, plus 1 single period of about 50 minutes for each of the 24 weeks. This amounts to approximately 4.5 hours per week, or 56 hours. The 56 hours are broken down as follows. 36 hours are instructor-led contact hours, which also include practical sessions. And 18 hours are instructor-led contact hours dedicated to practical tutorials on computers. In addition, a further 10 hours per term, equivalent to about 1.5 hours per week, are required for students to practice on their own to reinforce practical skills. These 10 hours should be in labs provided by the college for students to use.
Do I need extra resources to teach robotics and industrial automation?
The syllabus provides specific computer lab setup guidelines and resource requirements for all 3 NQF levels. The specifications include guidelines for furniture, electrical, ventilation and air conditioning, networking infrastructure, a data projector and screen, a desktop computer for students, a desktop computer or laptop for lecturers, a server, a UPS, desktop configuration for a Raspberry Pi lab, and the relevant software. For a college to set up and maintain these resources, they need a technology service and maintenance plan, a management plan, and the necessary budget.
How is the course assessed?
The curriculum requires that students are assessed via 2 components, an internal assessment of 50%, made up of only the ICAS, and an external assessment of 50%, made up of the ISAT, which is worth 15%, and the external exam, which is worth 35%. The task quantity weighting of ICAS is made up of 2 tests which count 10% each, making a total of 20%, plus 2 practical assessments of 25% each, which together make up 50%, plus 1 internal examination, which counts 30%. The external assessment is made up of Paper 1, a theory paper, which is 3 hours long and is out of 100 marks, and Paper 2, which is a 4-hour design-related paper, out of 80 marks. This table shows how each topic is weighted in the 2 exam papers. The cognitive levels for exam assessment will be distributed as shown.
How can TVET FIRST support lecturers and students?
The TVET FIRST Students Book is written by an examiner. It covers the 2025 curriculum completely and prepares students to succeed in their exams. Clear explanations guide students through the curriculum. Plenty of full-color screenshots, photographs, and diagrams support the text and make the learning experience fun and interesting. The book uses a step-by-step approach to teach problem solving. The student's book includes varied activities to help students consolidate their knowledge through practice. Summaries and exam-type summative assessments at the end of each module are excellent tools for students to revise the work and prepare for exams. The student's book also includes all the required practicals for the subject. TVET FIRST has a handy integrated workbook, which has all the practical projects for robotics and industrial automation and EDCR Level 4.
Are there any digital extras?
Yes. Have a look in the student's book and you will see QR codes that link students and lecturers via their phones to interesting and practical online videos.
How does TVET FIRST support lecturers?
TVET FIRST has a fabulous lecturers pack to make lecturers' lives easier. The pack includes the lecturer's guide and a USB which you can plug into your computer. The USB has year planning documents, study notes for students, and PowerPoint slide presentations for all the topics in the student's book. The lecturer's guide has information and resources for lecturers, including comprehensive answers to all activities, links to online materials, photocopyable lesson plan templates, and a 40-week teaching plan. TVET FIRST textbooks are approved by the DHET and trusted by lecturers. For the best results, trust TVET FIRST.